Hello viewers, welcome to my channel Shraddha's Physics. This video is specially for the aspirants who are preparing for OSSTD, KVS, NBS, regular teacher or any graduate level teacher exam. So today our topic is work done by a constant force. So let us consider a force F is applied on this object so that the particle or the object moves from the position A to position B along the x-axis. So we have for the F force, for this F, so it has two components along x-axis and y-axis. So we have considered here, so there is no motion along the y-axis. So suppose this F vector equal to Fx I cap plus Fy j cap. Fx is the component along x-axis, this is Fx, and I cap is the unit vector along x direction, and Fy j cap means j cap in the y cap direction, and Fy is the magnitude along the y direction. This is the y component of your force. So we can calculate the value of this Fx, that is, suppose let us draw so this is suppose a vector and it makes an angle theta with the x-axis. Suppose this is x-axis, so it makes an angle theta. So by drawing a perpendicular on the x-axis, this is suppose x-axis and this is suppose y-axis. So this is suppose Fx, this is Fx, and by plotting a perpendicular on the y-axis, this is suppose Fy. So from this triangle, we can say that this cos theta in this triangle, my cos theta equal to Fx divided by F. So this is Fx by F, or we can simply say that Fx equal to F cos theta. So this Fx equal to F cos theta. Similarly, we can write sin theta equal to, sin theta is P by H. So sin theta P means this side. So as this is Fy, this side is also Fy. So we can write sin theta equal to Fy divided by F. So Fy equal to F sin theta. So Fy equal to F sin theta. So let us consider that the displacement is along the x-axis. So we can write simply S vector equal to S into I cap. So for the work done, that is W equal to F dot S. Here F vector is given Fx I cap plus Fy j cap. Since the motion is along your x-axis, so simply writing S vector as your Si cap, we can write I dot I is your 1 and J dot I is 0. Since I dot I is 1, so this is Fx into S. So W equal to Fxs, or we can write simply Fx equal to F cos theta into S. So this simply implies that the work done is along the x-axis. So we can write work equal to the component of force along the displacement. It means that this F cos theta represents the motion or the force, the component of the force along this direction, that is F cos theta. This portion is F cos theta. So this is the component of force along the displacement into the displacement, that is S. This is the work done by the body. So W equal to, simply we can write F dot S means Fs cos theta, or this is the force into the component of the displacement along the direction of the force. And also we can say that work is a scalar quantity and its dimensional formula is m1 L2 T minus 2. So you can calculate this from the unit of your work done. So the first case, suppose this theta, this W equal to Fs cos theta, when this theta lies between 0 to 90 degrees, suppose for theta equal to 0 degree, theta equal to 0 degree means the force is applied on this direction, that is on this direction, theta is 0, on this particular direction. So it means cos 0 is your 1. So W equal to Fs. So this is that is force and displacement are in the same direction. So here work is said to be done upon the body. For example, we can see that the work done by the engine is positive. That is, engine of a car exerts a force on the car in the direction of propagation. Or otherwise, we can say that, suppose another example, let us take another example, a block placed on the table and being pulled by a string has positive work done by the applied force. So suppose this is the block and it is displacement along this B. So if we pull this object A along this direction, that is when the theta is 0 degree, along this direction, it means the direction of the displacement. So we can say that this is the positive work done. Similarly, a body falling freely under the action of a gravity has positive work done by the gravitational force. Case 2, that is 0 work. When the 0 work, if theta equal to 90 degree, theta 90 means cos theta is 0. So W equal to Fs cos theta becomes 0. So this will happen when the force acts in a direction at right angle to the direction of displacement. That is, no work is done. So along the displacement and the force, when they will act on the 90 degree or perpendicular to each other, at that condition we can say that there will be no work done. So for example, a person carrying a box over his head and walking on a horizontal road does no work. That is, force is perpendicular to the displacement. Second example, a student sitting on a chair and studying a book does no work since no displacement. This one is most funniest thing, I think. So next example is, when a body rotates in a circular path, centripetal force acts on it and displacement are perpendicular. So the centripetal force does no work. So a body undergoing rotational motion in a horizontal plane can rotate without any change in its kinetic energy. Next is, when a body is displaced along a horizontal surface, no work is done by its weight mg since it is always perpendicular to the displacement. So the moral of the story is, that is, when the displacement and the force, they will act in the perpendicular direction, so there will be no work done or the zero work done occurs. So the case 3 is negative work done. So when the theta lies between 90 to 180 degree, it means when theta is 180 degree, simply cos theta we can say, that is minus 1. So W equal to Fs cos theta, that is W equal to minus Fs. When the force and displacement are in opposite direction, we can say that work done is negative or work is said to be done by the body. When work done is positive, work is done upon the body, but when the negative work is done, it is said that work is said to be done by the body. So for example, when a body is pulled over a horizontal rough surface, force of friction and the displacement are opposite to each other. Our second example is, when brakes are applied to a moving car, the frictional torque supplied by the brakes retards the rotational motion of the wheel. Or when two similar charges approach each other, they repel each other, the force and displacement are opposite to each other. So we can simply say that when the force and displacement are in the opposite direction, we can say that the negative work will be done. Next is work done by a variable force. So we have seen that these are the examples of that we have discussed, that is for your constant force. Now here, work done by a variable force. Simply W equal to integration over F cos theta into ds. So case 1, if F and ds are parallel means theta equal to 0 degree. So W equal to simply integration over F ds. In case 2, if F and ds are anti-parallel means theta equal to 180 degree, or you can simply say that force and displacement are opposite to each other. So in that case, W equal to minus integration over F ds. So the case 3, if F and ds are mutually perpendicular, it means theta equal to 90 degree. In that case, work done is 0. So what are the units of work? SI unit is joule, CGS unit is org, and 1 joule equal to 10 power 7 org. These are known as the absolute units of work. And what are the gravitational units of work? In SI unit it is kg meter, and in CGS it is gram centimeter. Or simply W equal to Fs can be written as, if force equal to 1 kg weight and distance s equal to 1 meter, then work done is 1 kgm, that is in SI unit. And in CGS this is F, in CGS this is gram centimeter, or work W equal to Fs can be written as, for F equal to 1 gram weight, S equal to 1 centimeter, so W equal to 1 gram centimeter, and we can say that S kgm equal to 9.8 x joule, or x gram centimeter equal to 980 x org.